Good morning, everyone, and welcome to our next webinar for the Concrete Sustainability Hub. My name is Randy Kershane. I'm the director of the hub and just want to welcome everyone. We have a really exciting topic today. I'm not going to say too much today because I want to make sure we have as much time as possible for Dr. Howran Lee to tell us some of the exciting developments we have on Pavement LCA and more importantly, how essentially everyone can carry out their own analysis now because of a tool that he has led the development of. I wanted to point out it's a little over 10 years ago that the hub had its first publication around LCA and pavements. And along the way, we've continued to develop the toolkit to be able to model many different aspects of the way that pavements interact with the environment and have economic consequence. And a few years ago, we started to get so many requests for how do we do this kind of analysis for our location, for our case, it was clear to us that it was time to develop a way that folks could do that analysis themselves. And we're really happy and proud to be able to announce today that we have a effective tool that's freely available. I'm not going to I don't want to steal any more thunder, so I'm going to turn it over to Dr. Lee here to tell you about the work that he has done to make this possible.
All right. Thank you, Randy, and thanks for the brief introduction of the tool. So my name is Harley. I'm working as a postdoc associate at the Hub. So today I'm going to be very excited to share with you guys about the official releasing of the MIT Concrete Sustainability Hub, Streamlined Pavement LC and LCCA tool. So today I will walk you through with the tool, what is the workflow to run a pavement LC and LCC using the tool, which is only available now. So I will welcome everyone to try it out and let me know if you have any questions, comments. So today I will start with my presentation, which is from decisions.
Sorry, I'm sorry to interrupt you, but I was given one other task and I failed on it, which is that I want to make sure that everyone knows we're going to keep this relatively brief, so there's lots of time for questions. And the best way to get your questions out there for Howran is through the Q&A feature that should be available to you in Zoom down there at the bottom. And Andrew Laurent, our communications director, will join us at the end to tell you about how we'll distribute the slides and video for this. So sorry about that, Howran. I was supposed to cover that before handing it off to you, but I just want to make sure everyone knows how they can get those questions to you. So please go ahead.
Good. Okay. Yeah, so I'll continue. So just today, I will walk you through from the design of the pavement to the decision making as the practitioner, pavement designers, or decision makers or state agencies who could use the tool to make better decisions for low carbon and cost-effective choices for different pavement alternatives. So we'll start with why do we need a better pavement decision tool? So for existing tools, we have observed when we're trying to do LC and LCC, we need an EPD tool, we need an LCA database online, and then we need a practical use phase modeling to model the use phase impact of the pavement LCA. And also for the pavement design, we need a standardized AASHTO 93 or AASHTO mechanistic empirical pavement design guide, or you can call that AASHTO-aware pavement ME software to do the pavement long-term performance predictions and design. Reversely, we'll design a pavement, but we haven't explicitly include LC and LCC into currently pavement design practice. And also to perform those LCA, you need a separate tool set online here. It may take about weeks of data analysis, data obtain, and also you may need more professional or domain knowledge to run those softwares or tools. But also because of this data comes from different source, and also those softwares have their own assumptions and definitions. So you may confuse with their inconsistent assumptions of the data. So finally, because you're obtaining the different pavement design or maintenance strategies from different source, when you put everything into the pavement design and analysis, it may make them relatively hard to compare, which is apple to apple. It's always come with apple to orange comparisons. So that is the reason we have developed the payment LC and LCC tool, and we aim to streamline this tool. So first, we integrate everything into the tool. First, we include the pavement design, including both concrete pavement and asphalt pavement. And also, we use surrogate machine learning models to approximate the pavement long-term performance. For example, we approximate pavement ME simulations for long-term performance, including cracking, faulting, IRI for concrete pavement, and also cracking, transverse cracking, fatigue cracking, rutting, IRI for asphalt pavement. So we aim to estimate long-term performance as much as possible with much faster responsiveness compared to the traditional pavement ME or action entry design tools. And also, more importantly, we incorporate those long-term use phase into our LCA and LCC analysis. So now all those components has been embedded into the Streamlined payment LC and LCC tool. In addition, because we use advanced machine learning models to surrogate those simulations, so in this case, this tool has been significantly reduced the computation time when we're trying to run the other different separate tools compared to all-in-one tools as the LC and LCC Streamlined tool here. In addition, so because we have the consistent assumptions, which all the data are used for design and predict the long-term performance for different pavement alternatives. So all the assumptions are consistent, including contextual, the climate data, traffic data, material properties, and the structures of the pavement alternatives. So lastly, we have built in this visualization and comparison components, which means when we're trying to design pavement, for example, we have a design A, design B. Those are definitely structural equivalent pavement design for the long-term performance perspective. In this case, we can easily compare the LC or LCC to those different design alternatives. And here is the full life cycle assessment and life cycle cost analysis framework has been evolved in our online tool. And as we just talked, we include the pavement contextual data from the geometric data, climate data, and material structure and traffic. So also we include the paving material mixture design. Basically, we give the mixture and their different EPDs from the material emissions of each components of the mixture. And also we design the pavement using the action history and actual MEPDG design guide. So in this case, after obtaining all those data, and we have the capability to calculate material or construction emissions, which belongs to embodied emissions. And also because of the pavement design will impact our long-term pavement performance. Those performance will also impact our decisions for maintenance rehabilitation. In this way, those long-term pavement improvement or deterioration of the performance will be contributing to our modules of the use phase, including pavement vehicle interactions, we call PVI, including both deflection, roughness, and also the albedo impact because of the surface reflective property, and also the long-term carbon uptake of the concrete material, or you can call that concrete carbonations. So you can see those dollar sign indicate that those modules and components has been involved in the LCC analysis. These belongs to the life cycle greenhouse gas emission, GG emissions. So all this contributing to our embodied emissions and use phase emissions, which consist of the full life cycle. So the workflow of the tool. So after we build all the modules and the framework, we have embedded them into the online software tool. So first, we describe the contextual of the project climate traffic for the software tools and design, mixture design, and each components. And also we design and evaluate the pavement structure, long-term performance. And also we propose the maintenance rehabilitations. Some of them are default and you can easily change them. And definitely because we want to compare different alternatives, we make it easier to compare and better visualizations of the LCCA and LCA components. So this is a QR code. So feel free to scan, use your phone. but I will keep this QR code along with the presentation. Don't worry if you lost this chance. Okay, so now I will be glad to officially announcement the releasing of the Streamlined Payment LC and LCCA tool. So now we have two platforms. Now you can using your laptop, your desktop, MacBook, any of your personal computer to log in using this website. But also you can use an easier way to use this QR code scanning, and which we have improved the mobility responsiveness of the mobile phone, for example, here. But it's under construction, not yet a app, but it's a better visualization on the phone using this website. Okay, so let's get started. So if you're the first time users, so feel free to register, but if you're old users, you can directly log in. So here's the username, email, and password. Don't worry if you do not have that. So on the right-hand side, after registrations, you will be able to log in, use your email and your password. Since we have recently did an update, significant update, so if you're a user hasn't been using that for a long time, feel free to just sign up a new account so you will be ready to go. Okay, so compared to last year, another documentations we have embedded in the tool, which is the documentation informations. We document every components of the LCA and LCCA tools. And you can see here, it's under the document in the website. Just click the button. And also, if you're using a mobile phone, you can also see this one-to-one, the same information page for you to understanding what is involved in the tool, what is the data source, and what is steps and strategies to use the tool, or if you have any feedbacks. And so that is also step 0. So because I have used the tool for a while for testing validations, so I have run a bunch of experiments already, our case study. So in this case, my dashboard has already different component, different cases have been run, and you can see the status are complete in the middle, and I'm the authors and create dates and modifications. And you can see I have different names, but I just use default names. But if you want to change, feel free to make any changes to reflect your personal case studies. And also, if you're finished one, but you want to make any modifications, you want to see the results, you can click this action buttons, and you will be able to edit it. So again, same thing. If you are visualizing, if you're using your phone, you can also see very similar materials or details using your phone. So officially, next is the first step of the LCA and LCCA tool. So as we just talked, we are able to first actually change the unit. So we both including the metric and empirical unit. But if you're good with the empirical units, so feel free. Just the first is to define your state. So because we have been working with Iowa, so I just start to select Iowa, but any state can be selected within the tool, which we cover all the United States states. So also another significant components here compared to last year's webinar is the cost parameters. We have included the asphalt price and concrete price, the unit price, and also we include the diesel gas price when it's used for the use phase computations. We also have the annual discount rate in the bottom. And also you can see all the same information use your phone and by scan this QR code. So as we just talked, if you want to see the metric unit, if you're from internationally, so if you click button, this unit change will be show up immediately. It's not cubic yards, but now it's cubic meters. And so because we define the traffic here using qualitative metric, but if you want to see the real data will be incorporating the calculations, feel free to click detailed traffic data. You will see this traffics. Because for this case, I don't have exact data from the DOT yet. So I just select my prior urban interstate as a medium reliability. On the right hand side is like all the medium regular pavement. So that is the default result, default data, which comes from the FAA Highway Statistic 2020, which are all publicly available. Because we have a large range of the traffic data, so incorporated uncertainty is necessary. In this case, we have the distributions on the right-hand side. We have include uniform, log normal, normal, or triangular distributions to better reflect your data if you have the experience for those traffics. And also you can see that using your phone. If you click next, you will see the third step. It's the mixture design. So the first come up with is the mixture design for Iowa, which is the representative Iowa state average for the mixture design for the 4,000 PSI PCC compressive stress. So you can see we have split those materials and their relatively mixtures in three components and to be calculated as the material emission factors. And just to let you know, so if you're do not have those detailed mixture design, but you want to run the tool, so that is totally works. So here I just have the average states for Iowa. But if you're advanced users, you already know your mixtures. Or actually, if you're designing your mixtures, you want to know your EPD as a result, as a unit values, what is your CO2, you can change up any of these components, and you will see that those final emissions will directly pop up whenever you change any values of those boxes. So again, we have the conversions of the units, and we have the conversion of the CO2 equivalents, cubic meters or cubic yards based on your personal preference. So again, this can be done using your phone easily. Next is another mixture design for another significant material, which is the asphalt. So for the asphalt material, so everything is pretty similar. And you have the unit change conversions, and you can select your state, which is a representative for your state's average. And the different components can be changed. And you can see your unit material emission factors based on the default or your personal inputs. So again, similar thing, phone is useful as well. Okay, another significant component as step 5 within the tool is the pavement design. So for example, let's assume our first design is the concrete pavement, joint plain concrete pavement, GPCP. So as you can see here, this involves different structural designs. And again, the unit can be changed. Structural, which include the very standardized surface PCC layers, base layers, subgrade properties, and dull bar designs, which are exactly the same as the pavement ME designs, which are most significant components impact the long-term pavement performance for concrete. So also, if you are having your own designs, so you can click these buttons to input your own range of your design. For example, in this case, I have a minimum of 6.5 thickness for my concrete surface, and also maximum 8. So I just want to make my dull bar between 1 inch or 1.25. So I'm not sure because I haven't got exact data, but that is what we assumed for this too. And also this gives the probabilistic and comparative components for the uncertainty analysis for the LCA. Again, so the material properties are most sensitive properties to impact the long-term pavement performance and for design perspective. Another addition is the maintenance rehabilitation schedules. For this specific case, it is default M&R schedules for this pavement about 33 to 38 years. You need about 100% dam gradients. So another components, if you do not have a design yet, or you want to use the tool to design directly, as we talked, we have incorporated both H293 and H2MEPDG design. And because of the uncertainty analysis, we have included about 100 iterations or Monte Carlo simulations for this specific case, but it's changeable based on your personal experience. And also the design life, the analysis period can be changed. Again, you can do that using your phone easily. The second one, let's assume it's asphalt pavement. So similarly, because we input exactly the same climate data, traffic data, and pavement contexture data, so this design I consider equivalence in terms of the long-term performance compared to the previous design one, which is a concrete pavement. So now let's just assume this pavement design just have 8.25 inch for my asphalt layer, which is a fixed. I believe this is very popular if the design already been done and the designers want just put there's no range of min max. I just have one design values. No problem. These two can adopt that as well. Again, there are different components, which is similar to Pavement ME. You have to, if you have the values, you may want to define the SAC banner type, effective banner content, air voice, electromodulus, etc. If you do not have, those are the default values for you to get an early sense of what will be the average or the default values if I have this 8.25 inch asphalt pavements. So I just want to get a sense. So no worry, you don't need to change anything. These two can adopt from the most extensive data you have or with the least data. You can also run this, get the results and make early decisions. Or it could help you to gathering more data if you want to make more precise decisions or results based on your case specifications. And also for the maintenance reputations, so you can see that there's a default 2 maintenance reputations for this given asphalt pavement, about 20-year, 18 to 22 years AC immune fill, about 36 to 40 years, that will be another AC immune fill for this case. And also you can design this using our embedded surrogate models, which we try to approximate pavement ME or accident tree estimations for the design thickness, and also the different material properties if you have. So phone is also supported. Okay, so here's the result visualization. So as we just talked, we have a built-in visualization components for this too, which help the designers, decision holders, stakeholders, and the policymakers to make better decisions. Because for this case study, we just run a hypothetical design, so we haven't got any data from the specific case. So for this one, that's why we have include the uncertainty analysis. As you can see that, so this is my LCA results. On the left-hand side figure, you can see I have a 95 confidence intervals labeled by the light blue, and also for concrete and asphalt. So because it's interactive, you can see my sample here. For the medium, if I want to see what is the trade-offs between those different components, different alternatives, what is the benefit time if I want to use the concrete pavement, and what is the trade-offs. So for this specific case, if you use everything default, the medium result tell you that at the year of 19, you start to see the switching, which concrete now after 19 years become relatively lower environmental impact, and asphalt become more impact to the environment. On the right-hand side is the bar plot, including different components of the life cycle greenhouse gas emissions. So we have to also have the very useful interactive components. For example, if you're only interested in your embodied emissions. So this one on the right-hand side now, we include everything from embodied and use phase. But for the agencies, if you're only interested in embodied emissions, feel free to click any of these buttons and you will see that. Okay, so now you will see this including only initial constructions, M&R related embodied emissions, and end of life. You can still make better decisions if you only care about embodied emissions. But if you're caring about both embodied and use phase, the whole life cycle, you will include everything here. And I will introduce a little bit more details of this bar plot visualizations. But here we have the built-in visualizations, which is interactive to the users, very user-friendly. And then this is the LCCA results. So signed by the dollar mark. And also because we have the distribution or uncertainty analysis for our traffic. In this way, we also have uncertainty analysis. Again, very similar to the life cycle GG emissions or the LCA results. We see the interactive figures tell us about 11 years. You see the benefit of using this design one, which is a concrete pavement. And also on the right-hand side, if you only care about the embodied cost, so you can see the agency cost comparisons as well. It's very easy, user-friendly, so feel free to try on your own computers if you're interested to see different components, or if you're the user, you want to see the use phase impact, so feel free to play with the tool. And another components we have include is the probabilistic and comparative payment LCA and LCCA results. So for now, I only show this LCA in this slide. You can also show that, you can see that in your phone. And again, these top two figures are also the medium of these LCA results for my concrete pavement on the left-hand side, and on the right-hand side is asphalt pavement. So the bottom is the probabilistic distribution. Because of the lot of uncertainties when I'm playing with the tool, because I don't have any given data from the detailed Iowa case study, so I have the distribution to at least tell me what will be the range of my life cycle greenhouse gas emission on the right-hand figure. It could be somewhere from 1.6 to 3.8 kiloton of CO2 per lambda mile. And the left-hand side probabilistic results show the distribution when which design is better. For this specific case study, means that the design one, which is the concrete option, it's about 100% winning when for all the possible futures, because we run those uncertainties and we do the statistic analysis to see which one is better. And also, we include that into the LCCA analysis. So again, the top is the median, indicates the embodied cost, use phase cost, and the total cost. The bottom show these distributions as well. And you can see, if we take a look at the bottom left, we can see now in terms of the cost, the decision could be slightly, the result could be slightly different, which means that now my concrete or GPCP is preferred 92% of the overall possible futures, which is lower than the 100% when compared to the life cycle greenhouse gas emissions, but it still make confident decisions, which means that you can confidently say that for all the possible futures, I'm confident over 90% of the results, my first design, the concrete design, is better than the alternative asphalt design for this given case study. Okay, so why it matters to agencies? So as we just introduced, the tool is pretty easy to use and pretty meaningful for making decisions, which integrate design, material, performance, M&R, LC, and LCC. It's faster project level screening, could be customized for any DOT practice. I will show that later. And it's defensible, sustainable, and cost-effective decisions. And also it's scalable across networks. So here I have a few case studies, but before that, I will just show what is this bar plot, what is the components for the LCA analysis. We have been including the carbonations and albedo or relative forcing. When the surface is darker, it's observed more relative forcing from the atmosphere, then the temperature rising, and when it's more reflective surface, for example, the concrete pavement, it reflects more relative forcing to the atmosphere, then it will make the temperature colder. Then those will be translated to greenhouse gas emission as well. So those are the use phase. You can see use phase emissions. And the dark blue is the embodied emissions, including A1 to A5 for my EPD or embodied emissions. And also the M1R also corresponding to this A1 to A5, which are the emission related to the M1R activities. So also because of the pavement long-term performance and it's a deflection roughness, those also the components of my use phase. So feel free to, and also the enough flex. So feel free to reach out to this online too, because as you can see on the red panel, we have the clickable link. When you click the link, we have the one-page information documentations. So you can see similar explanation, or even the embedded circuit modeling we have developed, which are already published in the journals. So you can see those model development as well. Okay, so here are a few very quick case studies we have performed with different duties. So because making smarter, better, which is more sustainable and cost-effective decisions, definitely makes sense for state agencies. So here's the Iowa case study. Actually, after we did that hypothetical Iowa case studies, so they reached out to us to really run the real case study for them, which is I-35, the softball. It's a 3-lane pavement, and we have obtained 2 pavement design, which is very similar to our default on the online too. But because they are doing relatively higher traffic, so the thickness for both concrete and asphalt are relatively thicker, about 11.5 for concrete surface and 14.5 for asphalt surface. And maintaining rehabilitations, we're using default values. So you can see that because we have obtained exact data from the decisions from the agencies, so we can just easily run those data and using the line plot cumulative life cycle greenhouse gas emissions, and to compare these 2 structural equivalent designs for the 50-year analysis period. And we can see that now the trade-offs or benefit time switch to about 15 years. And also for the whole life cycle, compared to the HMA alternative, the concrete is saving about 17 percentage of the life cycle greenhouse gas emission. Once coming to the cost, so when we got the real cost data from the given project, the bid data, so the initial cost for both payment are pretty similar. So there's almost no time to wait to see the benefit. But also for the long-term runs, the total 50-year, we'll see about 16% of a cost reduction. Another quick runs we got, we have played with the Texas case studies. When they reach us, they can easily say that, okay, so for the business euro, so they see a very high RI curve and life cycle greenhouse gas emissions because it is a CRCP overlay of the GPCP, which is US 75, because they don't have detailed instructions of the surface treatment, which means that their contractor didn't do anything of the surface treatment after this overlay, but they immediately observe a high IRI. They reach out to us and to see potentials because they see the benefit of the dam grinding, but they're not sure how much dam grinding they have to do and what is the benefit. So we just run the 2 very easy to set up the different levels of dam grinding. For example, dam grinding to 95 inch per mile or to 65 inch per mile. And you can see directly saving of about 55 and 85% of the life cycle GHG. And what is the future of the 2? So we can actually customize the use for the state agencies as we just did. We can run customized case studies when we're giving the data. And also we can customize the pavement material structures to including, for example, more types of a concrete overlay, asphalt overlay, CRCP or RCCP. And also we can customize the performance modeling because we're using surrogate models to approximate MEPDG prediction. So we're able to using local calibrations because we're using exactly the same empirical equations to translate our predicted damages to the measurable distresses. And also, you can use the advanced machine learning or AI tools to do optimization, which you want to find a balance point here, or you want to reduce your life cycle cost or life cycle greenhouse gas emission. So in the future, we can do that as well. So actually, we have already built up that models to be already already have that models in hand, but haven't embedded in the tool because of the lack of the research and the publication of the tool, which you can include the design optimization, maintenance rehabilitation optimization, if you already have a payment there. And if you want to make better decisions for the very early age, you can do a whole lifecycle optimization, including design and M&R. So here is a quick example we have run for Indiana, which they're very interested in this optimization opportunity to reduce their both cost and the GG emissions for their I-65. And you can see that when we have business euro, and we have about 1.55, 0.77 for the GC and cost. When we're only trying to optimize design, we're saving about 2 to 6% respectively. And when we're on optimize the M&R, they're about saving up to 5% of GG, but slightly increasing about 1% of the cost. But if you want to make a better decisions much early age, you can save in both the GG and the cost by 9% and 60% respectively. So takeaways. So again, very excited to release the tool. It's a one platform for life cycle, integrate design, performance, M&R, LC, and LCC in a single workflow. You just need minutes instead of weeks and much more easier to implement and very easier comparisons because of the built-in visualization. And the third is DOT or state agency ready, customizable, and scalable for low cost decisions. No matter you're at early design stage or you're already there, have a payment, it's all can be helpful for reduce your cost or GHGs until the end of the payment life cycle. Okay, so feel free to use this website. I will keep that for about 10 seconds for you to take a screenshot of the user phone, scan this QR code. So feel free to use that and leave them in the comments. So I will be love to see a much popular group of our users and any types of comments, user interactions, and or the modeling on the backends. So feel free to let me know if you have any questions about the tools, suggestions, comments. Okay, so here's the end, and I will take comments from now, and I
Yeah,
will take to yeah.
absolutely. Thanks, Aaron. That was great. The I was actually going to ask you about the way folks can contact you. So there it is right there. And just to make sure I'm right, the QR code that's on the screen now is the same, just slightly smaller than the one that you had up there before. So if anyone missed that, you should still be able to get it right away. And I think Andrew put into the chat the actual URL, and now he's copying in the email addresses. So we've had a few questions. I'm sure the other questions will come up as we're talking here. Um, I'm gonna start with one that's fairly simple, I think. Well, let me just pose it. Would the software as it's currently configured allow us to compare two rigid pavements? Is that possible in the way that
Um, so for the built-in visualizations, it's not yet to compare the same materials, but you can
okay,
run twice of your case
okay,
study and just get the result
okay.
comparisons.
And the question was posed as to why that's the case. I think, to be honest with you, I think that was we had some beta testers of this, and that never came up as one of the suggestions. But I think we could put that on the short list of things that would come out in maybe version 1.1 or something like that. So thanks for that comment. And it's not a modeling limitation. It's just a user interface limitation as it is right now. So thanks for bringing that up. Another individual asked, as we So I had asked you to throw in at the end there some vision for the tool, and you gave kind of very big picture vision. Things like the last question are kind of maybe smaller tweak future visions. I think this next one somewhere in between is, do we have on sort of the roadmap to include other life cycle categories, or how much effort would be required to sort of expand out so that we're not just looking at greenhouse gases but other life cycle impacts? um
Yeah, that's a good question. So I think for us, because we focus on the life cycle GGs, but if we see potentially a let's say the other components of the GG, not only CO2, we can incorporate in the future, but not in our roadmap yet.
Yeah. So I think specifically what they're talking about is other impact categories. So things like other impacts to human health, other impacts
Oh,
to
yeah.
ecosystem, midpoint things. This question specifically mentioned some midpoints like eutrophication and acidification. I think from a modeling perspective, it wouldn't be difficult to include. I think we'd have to think about how to expand the visualizations to some degree. So maybe as like a midterm modification, we might be able to include some of that in like a tabular output without a significant visualizations, as folks can imagine, can be somewhat resource intensive, maybe to create. That might be another way to put it. The same individual asked us, what are the source for the current emissions data, like for materials and vehicles and things like that?
For the materials for concrete, this data from the NRMC industry average for concrete materials, and asphalt is from the NAPA EPD data,
Hmm.
and they're also varied from different state, different mixture designs. So it's pretty up-to-date data, and which are publicly available. And for the use phase, we're using the highway statistic traffic and the different cars and vehicles, truck, and their fuels are from those average fuels for the trucks and the cars and the cost as well. So, and
Hmm.
also they're modifiable if you are having your own data as well. It can be reflect better your personal or your specific case study if you
Hmm.
have that data in hand.
Yeah. Yeah, and so maybe this is just a good time to loop back to the point that you made at the beginning. Like any kind of software that's sort of first being deployed, we're sure there's lots of things that can be improved. So as folks use it and have questions like this, please let us know, because things like documentation of these types of things, that's fairly straightforward for us to do. Um, we have an interesting question here. So, say that a state only has asphalt pavements, or I think presumably what the question is like, say they were only interested in looking at asphalt related designs. Does there value for this kind of tool in that context? Like, how
Yeah,
would you see? Yeah, go ahead.
yeah, I think it's pretty similar to the first question. So
Hmm.
I think next version 1.1, so we will be just allow a more flexible design. If you are only interested in asphalt or concrete, you can have different asphalt is AC thickness, base thickness, and air voids, effective binder content. You can also compare your different M&R strategies to better see which one is the better decision among your practice. So that will be realized in the near future as well.
Yeah. As a matter of fact, in most of the cases that you showed, either the concrete design or the asphalt design had multiple permutations. Just for simplification purposes, when you showed it, we only showed a couple in there. So oftentimes there were finer, detailed discussions like that going on. Um, so yeah, I think that especially once we get the ability in there to have same material for both cases, I think that it'll be particularly useful. Um, this is a just a call out to Andrew or Elise. I see that someone has their hand raised. Don't think that there's a mechanism. I think the mechanism to pose a question is through the Q&A or the chat. Is that right?
Yeah, that's
Andrew?
correct. Unfortunately, we're unable to allow you to speak, so please use the Q&A feature.
Yeah, yeah. Sorry about that. But anyways, coming back to the question, we have this is sort of a big picture question, which is how would an agency verify that the models and assumptions are not partial to one kind of pavement over another, so concrete or asphalt? What would be some thoughts that you had? Like maybe maybe another way to think about that, Haran, is like any new user of a tool would want to make sure that it kind of reflects their own values or their views on the particular situation that's being evaluated. Like, how would you imagine someone tackling that for this tool? Like, what should they look at? What should they confirm that they agree with?
For design, I think actually it will be easy to validate it by compared to the action entry or actual MEPDG or payment ME. So you can compare the design, or actually, if you're feel comfortable, you can directly pull up that the design thickness, stop bars, and different component inside the tools. So that will be easy to validate. And for the LC and LCC parts, so I think the best way is to get your data and to see um, compared to uh, the the traditionals or your previous case studies, and to
Hmm.
validate if the two reflect your states or your local visions for the LC and LCCA.
Yeah, and I think in each of those cases, the user has the opportunity to essentially kind of override that, right? So, like if they
Yeah.
want to have a different design, they have the opportunity that if they want to have a different um, M&R schedule, maintenance and rehabilitation schedule, they can override that. If they want different assumptions about the materials, probably the one thing that like if the models that we have developed on performance were differing from that, that's something they might need to reach out to us and we could explore whether there was some way to calibrate it to their particular
Yeah, definitely.
situation. So
That's actually very realistic in the future as well. So
yeah,
when we talk to Iowa and Indiana, they have some local calibrations. We can directly incorporate in the performance and prediction in
yeah,
our tool. We just haven't released that to a general public. But it's very easy because we follow
yeah.
exactly the same framework as
So that's
actual.
something that hopefully in a future version that'll be and in between it we could try to work with folks to do that. So a related question is actually the last question that came in is have we compared the performance of the models, the underlying performance models with the outputs of things like ASHTO or MEPDG? And if so, could we point folks to resource? So I know the answer to that is yes. And so probably the real question is could we make available maybe when we make the recording and the slides available, Haran, we could also include links to the publications that have been done on the
Yeah,
comparison
definitely.
of the
Yeah,
model
sure.
performance there.
Yeah,
Yeah.
as we introduced, so we have those papers already there that
Yeah.
include everything we have developed. And also in the visualizations, I haven't included all the visualization, but we have the performance visualization as well. It can be directly pop up to compare with the action entry or MEPDG.
Oh,
And
okay.
feel
Well,
free to find the links to see how those models was validated, was developed, and how the performance compared to those standardized tools for
yeah.
payment performance.
Um, what if someone what if someone wanted to use this for a province in Canada? Do we have what would need to happen there?
Um, Actually, it's pretty easy. We just haven't incorporated the Canadian provinces, but because Canadian is using exactly MEPDG designs, it's very easy to incorporate into this tool. But for now, the tool is only focused on United States for now.
Okay. Okay. So we don't have a real simple solution for that. But again, if someone wanted to reach out to us, we could, like, it's structurally would be pretty easy to do.
Yeah.
Um, we, so I can answer one for you. There's someone that asked about what about the opportunities to link to pavementdesigner.org. That is certainly our vision for this. That's always kind of been our vision for it. And so hopefully in the upcoming year, we're going to try to find ways to. We've fortunately, having had that in the back of our minds along the way, I don't think it'll be a modeling challenge. I think it's more just sort of an implementation challenge. So look for that coming out in the future. We also had a question. Any thoughts on including? So I have to admit, I don't know what this particular standard, but ACI 330 for things like parking lots, warehouses. Um, um, do you feel like that would be something a reasonable extension of the tool for? Yeah, go ahead.
Yeah, I would say it could be some midterm of the tool. For now, we are focusing on the roadways and the parking lot could be included at the midpoint when we have the tool uh, developed already for the roadways, and also we can potentially incorporate the airfield as well in the
Mhm.
midterm.
Yeah, and then we have kind of one final question. I think it's really kind of a suggestion from Eric here, just to in the same way that we might want to look at multiple, say, multiple same material options, probably also want to be able to look at multiple M&R
Yeah.
options as well. So we will definitely, again, that's not a modeling challenge. It's really just a user interface kind of a thing that needs to be implemented. So that's the questions that have come in so far. I do want to just reiterate to everyone. I think we've had some good. We're grateful to the beta testers that we had to make sure that things work smoothly. But of course, we always that will never capture all the different kinds of functionalities that people can imagine. So please reach out to us as you have ideas on how tool can be improved. But we are really excited to get this out into everyone's hands, and hopefully it will be useful. And as a community, we can make it even better. So I think with that, I'm going to thank Howran again, and then I'm going to hand it over to Andrew Lawrence to just tell you a little bit about the logistics of how we'll get some of these resources to you and what's coming up.
Okay, absolutely. So, first of all, thank you to our presenters and our audience for an excellent discussion. I think I was very happy with the attendance and then just the level of engagement through the Q&A. So, thank you for that. So, please feel free to reach out to Howren and Randy with any questions that come up as you use the tool. As for distributing the materials from this presentation, the recording will be posted on YouTube, and the link and the slides will be sent to each of you via email. And then I have one exciting announcement. The CSHub will host its next webinar on February 26th. Professor Admir Masic will join us to talk about recent progress in the energy storing multifunctional concrete space. So please be on the lookout for email sent to you, and then also LinkedIn communications about that. So with that, thank you again for joining, and I hope everyone has a great day. Goodbye now.